In this example, we want to find an orthonormal basis for the subspace of R4 spanned by the following three vectors. All right, the first vector, 1, 0, 1, 0, is going to make up our E1. So E1 is going to be 1 over, we'll call this guy V1. This guy will be V2. This guy will be V3, just for the sake of being able to reference them. So E1 is going to be 1 over the length of V1 times V1. The length of V1 is root 2, so 1 over root 2 times 1, 0, 1, 0. Next, we need to come up with E2. E2 is a normalized version of W2. W2 is V2 minus the projection of V2 onto E1. Okay, so let's figure out that projection piece first. It's going to be E1 dotted with V2 over the length of E1. The length of E1 is 1 because we normalized it. That times E1. So we get E1 dotted with V1. So we get 1 times 1 is 1, plus 0, plus 1, plus 0. So that's 2 divided by root 2. So we get 2 over root 2 times E1. Sorry, that's V2 minus 2 over root 2 E1. Can't forget that part. And E1 is, of course, this vector times 1 over root 2. So the root 2 is multiplied together to become 2. 2 divided by 2 is 1. And so this is really just my vector 1, 1, 1, 1 minus 1, 0, 1, 0. And so that gives me 0, 1, 0, 1. We need to normalize that to get our E2. So 1 over the length of W2 times W2. And the length of W2 is root 2. So 1 over root 2 times 0, 1, 0, 1. Okay, so that gives us two of our basis vectors. How about we find W3? W3 is going to be V3 minus the projection of V3 onto E1 minus the projection of V3 onto E2. So this is going to be V3 minus the projection of V3 onto E1 is V3 dotted with E1 over the length of E1, which is 1, times E1. The projection of V3 onto E2 is V3 dotted with E2 onto E1 squared, E2 squared, I should say, times E2. Okay. So this is V3 minus V3 dotted with E1. So minus 1 times 1 is 1, and then 0, and then 0, and then 0. So you get negative 1 over root 2, because it's multiplied by 1 over root 2. This piece is 0. E1 is 1 over root 2 times 1, 0, 1, 0. Minus V3 dotted with E2. So we get 0 times negative 1 is 0, 2, 0, 1. So 2 plus 1 is 3. You get 3 over root 2 times 1 over root 2 times 0, 1, 0, 1. So this is V3 negative 1, 2, 0, 1. Double negatives cancel, so plus a half, 1, 0, 1, 0. Minus 3 halves, 0, 1, 0, 1. Which is equal to negative 1 plus a half is negative a half, minus 0 is negative a half. Two plus 0 minus 3 halves is positive 1 half. We have 0 plus a half plus 0 is plus 1 half. And we have 1 plus 0 minus 3 halves is minus 1 half, which we can rewrite as 1 half times minus 1, 1, 1, negative 1. And since this has length 1, right, we've got 1 plus 1 plus 1 plus 1 is 4. Root of 4 is 2. 2 divided by 2 is 1. So this is a unit vector. Okay, our orthonormal basis is going to be given by 1 over root 2, 1, 0, 1, 0, times 1 over root 2, 0, 1, 0, 1, and then a half minus 1, 1, 1, negative 1. That's a negative 1. And so that is an orthonormal basis for the space spanned by the given set of vectors.